Hi, in this video I'm looking at this integral here where we're integrating between 0 and pi on 4 of the square root of 10 on 10 plus 3x squared with respect to x. Now this integral doesn't quite look like it, but it actually is an integral that comes from deriving inverse tan. So the derivative with respect to x of inverse tan of some x on some number a is that number a on that number a squared plus x squared. So if we have the integral of some number a on some number a squared plus x squared with respect to x, then we are expecting that that is going to integrate to the inverse tan of x on a and of course plus c. So this doesn't quite look like this yet because I've got square root of 10, 10 and 3x squared. It's not quite number squared plus x squared. But we can fiddle with it and make it look like that. Because what we can do is we can rewrite some of those terms on the denominator. I can't really do much about the root 10. But the 10, well, we can rewrite that as root 10 squared. Because root 10 squared is still 10. And the 3x squared, well, we can take the squared out of the brackets and change what's on the inside. Now, x is still going to be x squared, but I need to somehow still have 3. So that means I'm going to have the square root of 3. Because the square root of 3 squared is 3. And of course we're still with respect to x. So now my integral looks more like this. I have some number and it's squared on the denominator, add on a term squared. But I needed just plain x squared there, but I've got this root 3x being squared. So that means I'm going to have to do a bit of substitution method. So I'm going to let u be this inner function here, the square root of 3x. And then I've got to derive that, so du dx is just going to be the square root of 3. And then I need to rewrite this, the dx is on its own, which is going to be du on root 3. So now I can substitute into this, and that will help me do my integral. So I'm going to have the integral between 0 and pi on 4 of the square root of 10 over the square root of 10 squared, plus we've replaced the square root of 3x with u, but it's still of course going to be squared, and our dx is going to be replaced with du on the square root of 3. So now this square root of 3 is kind of stuffing up our integral because we've just messed up this pattern slightly because we've now got this extra number floating in there. But that's okay, it's a constant, so we can bring that constant out the front of our integral. So I can bring that 1 over root 3 out the front of our integral between 0 and pi over 4 of the square root of 10 on the square root of 10 squared plus u squared with respect to u. And now I can actually do my integration because I'm in this form of some number on some number squared plus a variable squared with respect to that variable. So my integral, we have 1 over root 3, and we're going to integrate to this inverse tan. So we're going to have inverse tan of our variable u over our number, which is the square root of 10. And we're going to still be integrated between 0 and pi over 4. But these bounds, 0 to pi over 4, were with respect to x. So I've got to make this be back to being with respect to x. So I'm going to have 1 on root 3 outside of the inverse tan of -1. And we're going to put our u back in. U was root 3 times x. So we're going to have root 3 times x over the square root of 10 between 0 and pi on 4. So now I can substitute in and work out my numerical answer. So doing that, I have 1 on root 3 being multiplied onto the inverse tan of -1 of, we'll join our root 3 on 10 together, so we'll have root 3 on 10 multiplied by, substitute in pi on 4, and then we've got to subtract off the inverse tan of, again, we'll join that root 3 on 10 together, multiplied by 0. So now I just need to work out these two values and subtract them and then multiply by 1 on root 3. This second one is nice and easy because it's just going to be the inverse tan of 0 because we got root 3 on 10 times 0, which is 0. Inverse tan of 0, this comes out to equal 0. So we don't have to worry about it at all. So all I really need to worry about is 1 on root 3 times the inverse tan of root 3 on 10 multiplied by pi over 4. So if I go and chuck that into a calculator and get a numerical answer, we get 0.235 if I round to 3 decimal places. So there we have it. To do the integral between 0 and pi on 4 of root 10 on 10 plus 3x squared, it's really using this derivative of inverse tan knowledge. With a bit of substitution, work out all the numbers, and we get an answer of 0.235.